All right, here we go. So, fun times in math. Real quick, linear means that it adds on the same on each side, right? So on the x side, we're adding by 1, right? Increasing by 1. But if you try that on the y side, it adds 3, adds 6, adds 12. That is not linear because it's not adding the same number. So we say not adding. Instead, we see that it's doing what each time? That's supposed to be a multiplication dot times 2 times 2 times 2. So in this situation, we're multiplying each time. Same thing on the second table. Let's see if I can move this. That'd be awesome. No. All right. Well, anyways, let's try. Just do it. So on the left side, it's adding 1 each time. But over here, it's going down 50, down 25, down 12.5. So is that adding each time? No, it's not. Instead, it's multiplying by a half. Yes, multiplying by a half. So we have these two tables. You don't know what they look like on a graph yet necessarily, but you do know that instead of adding each time, you're multiplying on the y side. That's new today. And if you looked at the objective, we are talking about exponential growth. If you look at the paper in front of you, we're talking about exponential growth, right? And decay. So exponential. Yes, there are exponents in exponential functions, yes. So last class I did this on a PowerPoint, but we're going to try this way. So the notes haven't even started, so. Linear versus exponential. Now, real quick, y'all know these graphs? We just spent a whole unit on it, linear, okay? But, whoa. You want to miss my notes? Real quick. Real quick. Yes. All right. Now, exponential is what we're learning today, okay? And you need to know exponential growth and exponential decay. So, now here's the PowerPoint, but I'm doing it this way. So, on your paper, think about growth versus decay. Now, can you think of real-world examples of growth and decay that are kind of like those tables we just talked about?
Like people that have
Ratings. Okay.
like that.
Like stocks?
Yeah.
Okay. Yeah. You would like stocks to be exponentially growing. You know what? Here's the deal. When you think of linear, it's going to add the same number each time, right? So if I said I'll give you $1 each day, you'd be like, okay, cool. But if I said I'll double it each day, eventually it's like, okay. So here's the deal. Exponential has real world examples. Yeah. Can you draw a graph that has growth and a graph that has decay? Now, check it out. Here is what they look like, okay? So exponential graphs look like this. Do you see how they're not straight lines? There, you can take Herbie, okay? And by the way, we don't have headphones in here, right?
No.
Please? I didn't ask you here. Take off headphones, take off.
It says here.
I love wasting time on these videos talking about them. All right. So you just do it now. Yeah. Nice. I know I'll hide out on the side so you can put it in the other ear. All right, have a seat. Now, exponential is not adding the same number each time. That would be a straight line, but it's multiplying each time. Okay. You see how this starts with a little bit of increase and it gets super steep, super fast. That's exponential. Now, on your notes, okay, you're going to write something about exponential growth and exponential decay, okay? But I want you to know what it looks like. So on the right, this one is exponential growth. And on the left here, this one's exponential decay. Now, when you read from where to where? But, so, decay, if you're going from left to right, like you're reading, it goes down. Okay, so that's decay. From left to right, it's going down. Okay, and then for growth, from left to right, it's going up, right? So, do you see? Because I know they both go up, but you only think to the right. To the right, decrease. To the right, increase. Okay. So again, growth and decay. Now, on your little notes over here, for what is growth, I'll give you some options, okay? You could put that it's increasing by an increasing amount. Right? You can write that down. But everyone, write that right now. Write something down for exponential growth. It's increasing by an increasing amount, okay? And then off to the right, go ahead and draw yourself a little exponential growth. It's a curve going up to the right. Do your best. Okay, so it's increasing by an increasing amount. You could say it's curved. It's not straight, right? Decay is going to be the opposite. It's decreasing by a decreasing amount. It's still curved, but it goes down like this. And I do want you to draw a little picture off to the side so you know what the heck you're talking about. By a decreasing amount. So it's not a steady decrease. It's a decreasingly decrease. Okay. So that's why it's curved. All right. So now, did everyone write something down for those two? Okay, it's kind of whatever you think, but it's from what I've said. So again, decreasing by a decreasing amount. Now, the rest of these, A, B, C, D, E, F, okay, well, you need the image, which I'm going to put on the board. So we're going to do this by rows. Yes, actually. So, all right, so let's do this. Here we go. So you know what decay and growth look like. There it is. The activity is, I'm going to give you a graph, and you're going to tell me, is it linear or exponential? Is it growth or decay? That's it, okay? I'm going to go by rows. So now, for this class period, don't shout it out for someone else, please. Okay, now, here we go. Row over here. Is this linear or exponential? One of y'all two. Linear, it's a straight line, right? So you think it's growth or decay? Now, usually we would say positive slope, but yeah, growth. It's going up to the right. So go ahead and circle. So draw that real quick. In that box where it says A, draw a quick sketch. Right now, go ahead and draw a little straight line. It's linear growth. It doesn't have to be perfect. In fact, just a little sketch is all you need. So everyone did that on letter A. Draw a little line, and you said it's linear growth, right? For letter A. You got to do this with me because it's moving after we finish it. Okay, B. There we go. Second row. My second row people. Ready? Okay, so linear or exponential? What do you think? I know you don't have a headphone in. I know it. You do, though. So what do y'all think? Exponential or linear? You don't know. What do you think? Why is it exponential? No, but why is it exponential? By a decreasing amount. It's curved, right? Okay, so this is exponential, and you said, what is it? Okay, exponential decay. Everyone circle that. Draw that picture real quick and exponential decay. Does everyone know why? Down to the right. Okay. D-E-C-A-Y. I am.
Oh, God. I'm so proud of you.
So the first one is linear growth.
Yes. So we had A, you drew a picture, linear growth. B, you drew it, exponential decay. Everybody, we're moving on to C. Row C over here, okay? What is this? Row? Anyone in this row? What? Exponential. Very good, because it's curvy. At this point, that's all you need to know. Curvy, exponential. Cool. And then growth or decay, what do you think? Growth. It goes up to the right. Exponential growth. Draw it real quick. Draw it real quick. Like real quick. Take like 1 second. Draw it real quick.
Is it exponential?
Did you though? Because it's blank. Please. So, I want to move on. Let's go.
Okay. Wait. What number was it? What number?
Letter C, exponential growth. It's still on the board. Now, here we go. Letter D. Where are we at? Okay. Now, okay. This row. So we got. What do we got? Exponential growth, decay, or linear? What do you think? Exponential growth. You agree? Sure?
No, it's wrong.
No, It is right. So exponential growth is correct. Okay. So draw a little picture. You're a
Exponential decay?
No.
Is it exponential decay?
This?
Exponential growth.
Right. Yeah. Exponential growth. That's what they said.
Don't confuse me.
I'm not.
Don't
Okay.
confuse me.
A, B, C, D. All right. So next row. Here we go. All right. Linear or exponential? This row. What do you think? Linear? Is it growth or decay? What do you think? It's really negative, but yeah, you call it decay. That's fine. Okay. So linear, decay, whatever.
It's my turn.
Has everyone written down E? Again, this stuff takes seconds to do. Let's do it. All right. Now. All right. Next one. F.
My turn, right?
Oh, I'm out. Okay.
My turn?
There we go. Okay. This row. What do you think? Exponential, linear?
Exponential. 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 Growing and decaying.
Linear or no?
Have Samara answer it by herself.
You
She
sure?
knows what she wanted.
It's not linear. That's
You're right. Okay, it's exponential.
It's
Decay
exponential.
or growth?
It's growth. It's decaying.
It is decay.
I said decaying.
Exponential decay. I want to make sure everyone in your row knows it.
It's not saying.
Okay, so did everyone draw it? Put exponential decay?
Yes.
Okay. Now then.
Finish your story now?
Yeah, finish it.
All right, sorry. Here we go. Now, everyone, listen. You are. So you are going to. You are going to answer these. You're going to write in your own words how you know, as a person, individual, not me. How do you know if it's linear or exponential by looking at the graph? What's obvious about the picture? What did you look for? And then explain how you decided between growth and decay. How do you know? You said it over and over, but you write it down. Once people have written their sentences, then we're done with the notes, right?
Then you tell your story.
We'll think. We'll think about it.